Hello and welcome to the rest of lesson 1.4. So this is very similar to what I did for lesson 1.3. I already had a really great video on what's called the AC method of factoring trinomials. And all I wanted to add was one little last thought. I'm only going to work one example here, and if you need more, you can email me and ask me for more questions or ask me more questions. But you've seen the lesson for 1.4, and one of the key pieces there is that this thing called the AC method. So when there is a term or a number, a coefficient on this x squared term, I can't just do my beautiful little factoring skills that we learned for lesson 1.3. I have to do something similar but different. But as I mentioned in lesson 1.2 and the little addition to lesson 1.3, the first place you should always look is to see if you can pull out a GCF every single time. Now, a lot of times there won't be a GCF, but I just wanted to work one example with a GCF. And so that's what this little addition for lesson 1.4 is. Lesson 1.4 did not have a GCF example. So let's look here. I have 12x squared plus 10x plus minus 50. And one thing I hope you notice is that all of these are even, so definitely a 2 can be factored out of all of these. So if I factor a 2 out, divide by 2, 12x squared is 6x squared. Divide by 2 or factor a 2 out, that would become 5x. Bring down our subtraction, and 50 divide by 2 or factor out 2, that'd be 25. Okay, nice. Now there are no more common factors here. And so what I'm going to do is, I know this 2 is going to stay floating out front. I need to work on factoring this part, the trinomial that's following it. Now, luckily in the last lesson 1.3, when I pulled out a GCF, there was no leading coefficient left. It was understood to be a 1. So it was still an easy factor. But I have a 6 here this time. So I'm going to do what's called the AC method, which we covered in the video here. And AC means take, remember these are named the A term, the B term, and the C term. Take the A times the C and multiply it. And that's going to be the number that we look for things that multiply it to. So 6 times negative 25. So that would be negative 150. And whew, that's a big number. But that means I'm looking for two numbers that multiply to negative 150. And they have to add to the middle term, positive 5. Okay. Now what's really great about this is the same skill that we had or the same skill or same style that we used for our simple factoring, is looking for two numbers that multiply to something and that add to something. Okay, so, oh man, I don't think it's going to be 1, 2, or 3. So let's jump. Now, one thing I do want to show you is that you can really easily grab a calculator and you can just start seeing what divides into 150. So you could try 1 and 2. Those are going to be, when you add them together, if you did 2, it's going to be 75, right? So let's see, where's the clear button? If you did, 150 divided by 2, that's just 75. So the multiples there would be negative 2 and 75, or you could think of it as 2 and negative 75. But when you add those, you're going to be nowhere close to 5. You're going to be at 73 and negative 73. So these numbers are just way too far apart. They got to be 5 apart because one's going to be negative, one's going to be positive. So let's see. You could try something like 10, because I know this is divisible by 10. 150 divided by 10. You're like, oh, wait, we're getting into business. That's 15. 10 and 15 are 5 apart. Now, which one needs to be negative and which one needs to be positive? If I do negative 10 times positive 15 and positive 10 times negative 15, I'm sure one of these will give me positive 5. Let's see. Negative 10 plus 15. Oh, yeah, that's the positive 5. This one is the negative 5. So here we have our winner. Ding, 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 minus 10 and a positive 15. So remember, when the AC method, those aren't the pieces that make our two binomials. What we're looking to do is to make this something with 4 terms to be able to factor by grouping. We're looking to break the 5x into 2 terms. And what we're going to break it into is 10x plus negative 10x minus 10x plus 15x. minus 10x plus 15x. And you would agree that negative 10x plus 15x is 5x. So these are equivalent mathematical statements, equivalent expressions here on each side of this equal sign. And so I haven't changed the value at all, but what I've done is this is going to be something that should, if this factors, should factor by grouping. So I'm going to group it. Thank goodness there's a plus sign in the middle, so this makes it a little bit simpler. And I'm going to try to pull out a common factor, GCF, from both of these terms. Let's see, 2x looks like it would pull out. And what would we be left with? A 3x minus 5. I'm going pretty quick on the factor by grouping and the GCF stuff because we've done that a good bit now. If you're not cozy with how fast I'm going, take your time, pause the video, and make sure you understand. Bring down the plus sign. Let's see, what common factor goes into both of these? I would say 5 for sure. And let's see, if I factor a 5 out of here, I'm going to 15 divided by 5 is 3, so 3x minus 25 divided by 5 is 5. All right, now let's dummy check this to see if we have it right. And all I mean by that is, are these two groups of parentheses identical for the whole two terms? And the answer is yes, they are. If I look at the first term and the second term, do they have anything in common? And yes, they have 3x minus 5 and 3x minus 5. Brilliant. So notice this 2 is still just floating out there. Pulling out a GCF doesn't really hurt anything. It just sits out front. I may use brackets so you can easily see what we're doing. All right, if you don't have the brackets, it's no big deal. You would just have 2 times the two things we're fixing to factor, the two binomials. So notice both terms have 3x minus 5. So I'm going to factor out 3x minus 5. I have pulled that away from the first term here. So 3x minus 5, pull it away. What am I left with? 2x. Okay. I have pulled it away from the second term. When I pull or yank away 3x minus 5, what are you left with? Plus 5. All right, and so we have factored it. There's our answer. So the whole point of this little addition to lesson 1.4 was just that sometimes before you jump into factor by grouping, you need to look for a greatest common factor. Good question here would be, would it still work if I didn't pull out the greatest common factor? Yeah, absolutely. This 2 would be distributed into one of these. You would get an answer like 6x minus 10 times 2x plus 5. Or you might have gotten 3x minus 10 times 4x plus 10. Sorry, 3x minus 5 times 4x. The 2 would have been distributed into one of those two binomials. But you would have had to deal with much larger numbers. So before factoring out this greatest common factor, 12 times 50, oh my, this would be huge. And you'd have to find things that add to 10. And technically, if you didn't pull the 2 out at the end, you would not be all the way factored. But for most of the math we're going to do later in this course, that would be good enough factoring. You would figure out the same answer in the end. All right, so you should be good to turn loose and try this homework for homework 1.4. Good luck with it, and email me if you need anything.